Hello, my name is Nick McPhee, and this is the fourth of a set of 4 videos providing a simple introduction demonstration of shell scripting with Bash. In previous videos, we've taken the starter repository on GitHub, we've forked it on GitHub, we've cloned a copy on our local machine, we've seen how what the problem is that we're trying to solve and how the bats tests work. We have used the bats test to drive a very simple and incomplete solution that actually passes all but the last test. In this video, we're actually going to then finish up the last test by actually, in some sense, writing the script that was being requested. So the script we have at the moment has a shebang line which says that we're going to interpret all these commands as bash commands. There is currently one command, which is an echo, that prints out the line, there were 78 successes and 22 failures, which happens to be the right answer for the first test on a full file, but it's clearly not the right answer for anything else. That happens to get us through all but one of the tests. We have a shell script that exists, it is executable, it runs without generating an error code, it prints out one line, the line has the right form, there were some digits successes and some digits failures. It prints out the right number of successes, at least for files.tgz, it prints the right number of files for files.tgz, and then overall it prints the correct output for files.tgz, but it fails to print the correct output for second file set.tgz, where there should be 76 successes and 24 failures instead of 78 and 22. So now we're going to have to actually, as it were, solve the problem. We're going to have to pay attention to our input, and we're going to have to do the work that needs to be done. Okay, so first thing, if we think about how we're going to call this, we're going to call this count successes and then something like testdatafiles.tgz. So we're going to have a single command line argument that is going to be the tar file that we want this script to actually act on. Well, at the moment, we have no way of referencing that command line argument. It turns out that in Bash, when you have a script like this, command line arguments come in as variables with the names $1, $2, $3, etc. for the first, second, third command line argument. So we could, in our script, refer to $1. So I could say echo $1. And if we run our script, it's going to echo the command line argument. And that's this first echo. And then the second is it's going to print out our incorrect line again. So I could just use $1 to refer everywhere to the command line argument. I'm actually going to instead give it a name so that when we see that name, we'll know sort of how to interpret it. $1 doesn't convey much meaning other than the fact it's the first command line argument. So I could say instead tar file equals $1. And in shell scripting, if we have a variable name, an equal sign, and then an expression, the value of that expression will be assigned to that variable. Here the value of this expression is going to be the string that is whatever the command line argument was. So we're going to assign that to tar file. If we want to get the value of a variable, if we say $ followed by the variable name, that will give us the value of that variable. So this should do exactly the same thing. It should take $1, assign it to tar file, and then it should echo that out, print that out, followed by this. I should also point out that assignments like this, in the shell, you cannot have spaces around the equal sign. In most programming languages, spaces around the equal sign would be totally fine. Here, when we're doing a variable assignment like this, you have to run it all together or it won't work. So make sure I save. And if I run this, it does the same thing. That's cool. So now I've captured the shell variable, the command line argument, that's great. Now I have to do something with it. I have to extract that file and get all the things that were in it. So it's a tar archive, which means it can have files, it can have directories, it can have directories that have directories that have directories that have files. So I need to open that up and extract all the stuff somewhere. Now I could just do that in the directory I'm in, but then that would spill a bunch of stuff all over the current directory, which is messy and unpleasant. Worse, it could corrupt the results, because then I might end up counting a file that was already here that happened to have the word success in it as one of the success files, when I shouldn't have. It wasn't part of the archive and it shouldn't have been counted. It just happened to have the word success in it. So I really want to do work like this in a temporary scratch directory, because that ensures A, that my results don't get corrupted by other people's files or my own files that happen to be in the wrong place, and B, it makes it a lot easier to clean up after myself, because then I just need to delete that scratch directory when I'm done, and all evidence of my work will go away. This is a common enough issue that there is in fact a command in Unix for doing exactly this thing, and it's called mktemp. And M stands for make temporary, and it by default makes a temporary file. If I say mktemp, that created a file /tmp/tmp.fp blah blah blah. So it makes a file with a random string as part of the name, and it guarantees that this file will not collide with any other files that happen to already exist. So I want to probably remove that so I don't leave a bunch of stuff lying around. Now we want a directory instead of a file, which is in fact pretty common. It's more useful usually to have a directory. Well, make temp takes command line argument ---- directory that does exactly what we want. That now will turn out to be a directory if we do ls-l temp.d bloop. We got nothing because it actually showed us the contents of the directory. If we wanted to see the information about the directory itself, if we put a D here, then that says we want to see the -l, the long output, and we don't want to sort of open up directories. We want to see the information about the directories. So that tells us that yes, indeed, it's a directory. We see the D here and the blue color, which at least in my setup tells me it's a directory. So yay, we can make directories with mktemp. Okay, so I'm going to get rid of that temporary directory so we clean up after ourselves. Now, we could just say mktemp ---- directory, except that would make a directory, but we wouldn't know what it was called. We need to capture the name, because we need to be able to say later on, this is the directory we want to extract files into, this is the directory we want to count successes and failures in, and then at the very end, this is the directory we want to delete when we clean up. So we need to capture that name, and as we do in other programming, if there's a value we need to capture and refer to later, we need to give it a name. So I'm going to call this scratch, just as a name, and I can say scratch equals make temp directory. And that looks like that might be pretty promising. It is almost right, but not quite. It turns out if I do this, it's going to assign the string mktemp to scratch, and then have a fit because ---- directory isn't a command. And what I want here is I don't want to assign mktemp to scratch. I want to assign whatever this returns to scratch. And the way I do that in the shell is I put backticks, backticks around the command I want to execute and have the value of that assigned to scratch. So in general, backticks around an expression say evaluate that expression and replace it with the value that that expression returns. And then in this case, we're going to assign that value to Scratch. That gives Scratch a name. And if we replace the echo tar, well, we won't, let's not replace, let's actually just add a line, echo Scratch, and then run our script. Test data files. We get test data files, again, that's the echo tar file, and then we get Scratch. And if we look, ls minus ld temp, it is a directory, yay, it made a thing. Let's remove that, and that'll clean up after ourselves. And because I keep having to remove this, why don't we go ahead and remove, as the very last step, $scratch. So that, rmdir, to remove the directory, $scratch. And now, if we run the script, mktemp made a directory called temp.74 blah blah blah. But if we look for temp.74esqnvz3e, it's not there because we've now removed it. So it was created and then it was removed. Okay. So at the moment we have got a name for the command line argument. We've created a temporary directory. What do we do next? Well, next we're going to need to extract the contents of the archive into that directory. So how do we, let's get rid of our echoes. How do we extract the contents of a tar file? Well, there's a command tar that lets us create tar files and extract things from tar files. And tar can take a bunch of flags, and in many cases, if there's multiple flags, you can just run them together. So we're going to use the Z flag, which says that the tar file that we're working with is compressed. So it's files.tgz, it's a compressed tar file. We're going to use the X flag, which says extract. So we're going to extract the contents of the file. We're going to say F, which is, well, where is the file? And the file is in tar file. So this says extract the contents of a compressed tar file named whatever was passed in as the command line argument. So that actually extracts all the files. That's awesome. However, it will leave them right in the current directory, which we don't really want to do. We want to put them in the temp directory that we made. And it turns out that tar takes a ---- directory command as well that we can use to specify where the files ended up, which is cool. Now, I want to run this, but actually I want to see that it extracted the files. So I'm going to come down here and actually comment out, and then bash, if a line begins with a hash mark, that makes that line a comment. I'm going to comment out the rmdir line, and I'm going to put back the echo scratch line, so I will know where the directory was, and I'll make sure it didn't get deleted. So it should still be there when I'm done running the script, so I can go look in it and see if it's got the stuff I wanted. So things ran, and it says that the name of the directory is temp/temp.2n blah blah blah. So if I say ls temp.2n .2n, it contains a directory called files. If we say I want to look inside that, lo and behold, there's a whole bunch of output files. I'll tell you that's right. And if I want to look at one of those, let's say out of 22, it is just the word success. So And if actually less was probably overkill since these are just one line. 97, also success. Turns out most of these are success, a few of them are failure. So it does look like it extracted correctly and put things in the right place. That's good. So I'm going to remove my Scratch file. So rm dir temp.2n, boom. Oh, rmdir doesn't work. So it turns out rmdir, remove directory, only will remove empty directories. And my directory is not empty, it's full of stuff. If you've got a directory that's full of stuff that you want to get rid of, the easiest way to do that is rm -rf name of directory. Now, this is actually a quite dangerous command, so we should talk about it in a second, and you should be very careful when using it. The -r is recursive, which says if there are go into directories and go into subdirectories and sub-subdirectories, sort of recurse all the way through the tree, removing everything. And F says force. By default, rm-r is interactive. It will ask us about every file one at a time. Do you want to remove this? Do you really want to remove this? Which in this case, we've got 100 files and 2 directories. That would be really tedious and clearly not good in a script, because the user doesn't want to be surprised to find out they've got to remove what might be hundreds or thousands of, approve the removal of hundreds or thousands of individual files. So rm-rf is the right tool for the job here, but you need to be very careful with that. If you do this in the wrong place, you can really make a mess of things. If you did this in your home directory, for example, you could literally remove all of your files in one command. And it's not like trash where you can, or recycle bin or something where you can go and say, oh, I didn't mean to do that, and get them back, and they're gone. So be very careful with rm-rf. But in this case, this is the best way for us to get rid of that. So that gets rid of that, and that tells me that when I come back here, rmdir isn't going to work for me, and that I'm going to need rm-rf scratch. So this will be okay because scratch is the name of a temporary directory. No one else should know about it. No one else should have anything there. So we ought to be able to remove it and all of its contents safely at the end of our script. Okay, but this is definitely a place where you want to measure twice and cut once. You want to think carefully about, is this what you really want to do? Okay. So now we have created our temporary directory. We've got our command line argument. I'm going to get rid of this. We have extracted all the files, and then we remove the scratch directory when we're done. Now, all that's left is to actually do the counting. So we need to count the number of files that say success and the number of files that say failure. An easy way to do that, and I'm going to actually, to demonstrate this, I'm going to go in here and I'm actually going to tar zxf files. I'm actually just do this right in this directory. So now we have this new directory files. This has got all these files in. So I can show how this next part's going to work, and then I'll delete all this when I'm done. If we want to find where the word success occurs in a file, we can say grep success, let's say output file 0. And it says, hey, there's a line with the word success in it. Grep will take this pattern, the first argument, and a file name, and it will print out every line in that file that matches that pattern. So actually, if we come back to our top directory and we say grep tar in count successes, we get 2 lines that have the word tar in them. The first is where we assign tar file here, and the second is where we do the extraction. So we can use grep to find lines that match a pattern. And there's a lot of sophisticated things that we can do with grep, including regular expressions. We won't get into that now. Let's go back here. Now sometimes we don't really want to know what lines have that pattern. We just want to know, did the file have that pattern? And so if we say grep minus L success output file 0, we get just the file name. This is what's really cool, because we can say, oh look, let's actually do that, but instead of having it one file, let's hand it all the files, and we get a list of all the files that have the word success in. And perhaps more interesting, if we, because it's easier to look at, if we say show us the failures, we find that there are, not as many failures. And if I look at one of them, I don't know, 64, indeed it does say failure. And if I come up here to the successes and say I look at 87, 87 does indeed say success. So we can use grep like this to generate lists of files that have that pattern. Well, we want to count. We want to say, well, how many were there? And this is where word count, WC, is useful. If we take the results of that grep, which is this, and we say, well, how many lines are there? Well, ask word count. WC minus L says count the number of lines, that's the minus L, in whatever we hand to WC. So we're taking the output of this grep, and with a pipe, we're making that the input to WC minus L. And we get 22. And doesn't that look familiar? Oh, that's very nice. And if we say, let's do success instead, we get 78. How convenient. So that seems to be the right thing. Now, one last piece. Notice that I'm getting this by going into the files directory and doing this grep. We don't actually know whether there will be a directory, what it will be called. So this isn't optimal. Now, if I say grep minus L failure files, I get 0, and it complains that files is a directory. So grep's like, I know how to look at files, but I don't really know how to, well, individual files, but I don't know how to look at a directory. It does, actually. You just need to give it the -R flag, which says recurse. If you see a directory, go into it. If you see subdirectories, go into them, and find me all the files anywhere in that whole hierarchy that have this pattern, and then count them up. And lo and behold, we get 22, and we get 78. So we can say grep minus LR and the pattern, and then our scratch directory, and that'll say go into the scratch directory, look in there and everything below it, find the things that match the pattern, count how many there are, and give us that answer. So we could do things like grep minus LR success $scratch, and we need $scratch. If we didn't have the $sign, this would be look for a file called scratch in all capitals, and there wouldn't be one, and we would get grumpiness. And pipe that to WC minus L. Now again, that's going to give us a number, but we want to refer to that number later, so we need to capture it in some way. Well, like before, you capture it by giving it a name, a variable. So we could say num successes equals, and then we're going to use the backticks again to say evaluate this expression and take the answer that it gives us back, 22, 78, whatever, and assign that to this variable. And then we'll say num failures equals backtick grep minus LR failure $scratch pipe WC minus L close backtick. And that should do the counting. And now we need to actually insert those values inside this string. And it turns out that in the shell, if you have a string delimited with double quotes, this doesn't work if it's single quotes. If there are references to shell variables in the string, like we see here, then the value of that shell variable will be inserted in this location automatically. And similarly here, the value of that shell variable will be inserted here. So we should do the counting, assign it to these variables, and then use the values of those variables in this output. So, might work. Let's find out. Let's actually get rid of the files directory that I created, and let's say bats test, and we win a prize. All 9 of our tests pass. There are no failures. We have successfully passed all these tests, which include we get the right answer for this tar file archive, and we get the right answer for this tar archive, which suggests that we're able to look at different inputs provided as command line arguments and do the right thing with them. So actually we're in really good shape. I think we're going to call this good. We could add a little comment to indicate sort of what this does. Extracts contents of a compressed tar archive specified as the first command line argument, and counts the number of files that contain the word success and the number containing the word failure, and reports that result. And my name, University of Minnesota Morris, and August 2016. Okay. So let's make sure that it's still, everything still passes. Good. Quit the editor. Let's make sure we commit, and then we'll be done. So we have modified count successes. I appear to have a random file in test data, which I'll get rid of because I don't want to commit that. So we've modified count successes. If we have a look at what we did, we replaced this old one-line solution, quote unquote, that clearly didn't do anything, with an actual working solution that captured the tar file, created the temporary directory, extracted everybody into that temporary directory, counted the number of files that had the word success in, counted the number of files that had the word failure in, reported the result, and removed the scratch directory to clean up after ourselves. So git add count successes, git commit, got the shell script, let's say got the count, let's put that backticks, count successes.sh script working. It now passes all the tests and appears to be in good shape, ready for a code review. So if we were doing this in a more production environment, since I did this on my own, I didn't pair program with somebody, it would probably be good if I did some sort of code review with someone else before we push this into production and the company's life depended on it. So I'm going to save that and exit. So we've successfully committed. Now I have to remember to push, git push, and log in. And we have successfully pushed. And if we come over here and reload, got the count successes script working. So we got our message and our script. And so at this point we have a fully working version of the project. And if this had been, if there had been an issue that had specified that we wanted to write this script, then we could go into the issue tracker and specify that and close that issue and say, well, we got that done, but we're not going to worry about that at the moment. So just to recap, we captured the tar, the name of the tar file, $1, gave us access to the command line arguments. We gave that a name. mktemp allowed us to create a temporary directory. We saved that in a variable. We used the tar command to extract, that's the X, a compressed, that's the Z, tar file, that's the F, with this name, $tar file, minus directory lets us say what directory we want to extract things into, and we specify that we want to extract into the scratch directory. We count the number of successes by using grep. Minus L says just let's count the files that have the pattern. R says let's recurse into directories and subdirectories. We're going to look for the pattern success in the directory $scratch. We're going to take that list of files, run it through wc-l to count how many there were. We're going to give that a name. Same thing for failure. And then we're going to echo the number of successes and the number of failures. Finally, we'll rm-rf, our scratch directory, to clean up after ourselves so we don't leave a bunch of gunk behind. And that wraps it up. Thank you very much for watching. Definitely let me know if you've got any questions. Talk to you later. Bye-bye.